we are simplifying this expression here. The first thing you want to do is obtain common denominators. So you're going to multiply top and bottom of each fraction by something to obtain a common denominator. I noticed that they already have an x plus 2 in common, so I don't have to account for that. All I actually have to do is multiply top and bottom of this guy here by x minus 3, because this denominator doesn't have an x minus 3, and multiply top and bottom of this guy, this fraction, by x minus 5, because this denominator is missing an x minus 5. So multiply top and bottom of this fraction by x minus 3, and multiply top and bottom of this fraction by x minus 5. And look at that, now we have common denominators, x minus 5, x plus 2, x minus 3. So now that we have common denominators, I can combine the fractions. X minus 5, x plus 2, x minus 3. In the numerator, I have the first numerator minus the second numerator. Be really careful here, because this minus sign is going to apply to both terms that you obtain in this numerator. I can imagine a lot of people making a mistake there. So distributing the 6 here, I have 6x minus 18, and you have minus 1x, so minus x, and then minus negative 5, so plus 5. If you didn't get the right answer, it may very well be because you didn't distribute the minus sign to both terms here. Like a lot of people, when they multiply top and bottom by x minus 5, they won't write 1 times x minus 5. They'll just write x minus 5. And when they apply the minus sign to this numerator, they will only apply the minus sign to the x and not the minus 5. But this minus sign needs to be applied to the whole numerator of that fraction. Okay, so you're going to get minus x plus 5. Then we can combine like terms in the numerator. I see 6x minus x, so that's 5x. And I see negative 18 plus 5, so that's minus 13. I think that's it. I don't think that there's anything else I could do. There's no common factor to pull out here, so that should be done. 23. We have b squared minus 7b plus 38 over b squared minus 10b minus 24 plus 4 over b plus 2. And we want to combine those two fractions, which means we need common denominators. It would be a mistake to take this entire denominator and multiply top and bottom by that whole denominator. My bet is that if I factor this denominator, then b plus 2, like this denominator right here, will be one of the factors here. That's my guess. Just, I have a feeling that, yeah, that's what's going to happen. So b squared minus 7b plus 38. I'm not sure if I should factor the numerator. I don't even know if it does factor. The denominator, I'm looking for a pair of numbers that multiply to negative 24 and add up to negative 10. So that's negative 12 and positive 2. Yep, just like I predicted, b plus 2 is one of the factors in the bottom here, which means in order to obtain common denominators, all I have to do is multiply top and bottom of this fraction by b minus 12, because that's the only factor that its denominator is missing. So I'll go ahead and do that. So top and bottom by b minus 12. And now I have common denominators, so I can add the fractions together. So I have that common denominator of b minus 12 times b plus 2. In the numerator, what do I have? Well, I have the first numerator, which is b squared minus 7b plus 38, plus, and then I'm going to add this guy, so that's plus 4 quantity b minus 12. And now I think I'm going to distribute the 4 in that numerator, so that is 4b minus 48. And then I think there are some like terms which can be combined in the numerator. Let's see, I have a minus 7b and a positive 4b. I think that'll give me a minus 3b. And then I have a 38 minus 48. That would be minus 10. And then the only other thing conceivably that I could do here is maybe that numerator can be factored. And then maybe one of the factors like will cancel with one of the factors in the bottom here. So I need a pair of numbers that multiply to negative 10 and add up to negative 3. That is negative 5 and positive 2. So this guy factors as b minus 5 times b plus 2. And sure enough, like the b plus 2 cancels and you just get b minus 5 over b minus 12. So that's number 23. My God. 24. So for these rational expressions, what you have is a complex fraction. What that means is you have fractions inside of fractions. So maybe you have like a over b plus c over d over e over f plus g over h, stuff like that. Whenever you have a complex fraction like that, like fractions inside of other fractions, your goal is to combine fractions until you have a single fraction on top, like x over y, and a single fraction on the bottom, like z over w. Because once you rewrite your complex fraction in that form, the complex fraction will simply be the numerator divided by the denominator. In other words, the top fraction times the reciprocal of the bottom fraction. You know, you're taking one fraction dividing by another, so that's basically keep it, change it, flip it. Dividing by a fraction means multiplying by the reciprocal, and so you'll say, oh, that's x over y times w over z. But in order to keep it, change it, flip it, you must rewrite your complex fraction in that form. You have to get one fraction on top and one fraction down below, and most of the work for these problems is going to be done by doing exactly that kind of work here. So number 24, we have this expression. I see that I have two fractions in the numerator. I need to combine them, and I'm going to do that by getting common denominators. So that's, I'll multiply top and bottom of this first fraction by 3. So I get 3 over 3 quantity 4 minus x. And I'll multiply top and bottom of this second fraction by this denominator, 4 minus x. So I get 4 minus x on top, and then 3 times 4 minus x on the bottom. This x minus 1, I'm going to write it as x minus 1 all over 1. And the reason for that is, as I said, I really want a single fraction over another single fraction. Like I want one fraction in the numerator of the big fraction and one fraction in the bottom of the big fraction. And x minus 1 is not really a fraction. All right, so okay, so now that I have common denominators with these two fractions, I can combine them. You have to watch out. There's like a really common mistake that people will make here. When you subtract this second fraction, this minus sign must apply to both the 4 and the negative x. Like it has to apply to both of the terms of the numerator here. So you're going to get 3 minus 4 and then plus x, because minus negative x is plus x. And then on the bottom, I still have the x minus 1 over 1. Then combining like terms, I have, okay, 3 minus 4 is negative 1 and then plus x. I'd rather just call that x minus 1. Like we could call that negative 1 plus x, same thing. And the bottom I have the x minus 1 over 1. And now I finally have one single fraction divided by one single fraction. And so now I can finally keep it, change it, flip it. So I keep the top fraction, and then I change the division to multiplication, and I multiply by the reciprocal of the bottom fraction. So when you multiply two fractions, you just multiply across the top and across the bottom. So x minus 1 times 1 is x minus 1. And then on the bottom, I have 3 times 4 minus x times x minus 1. And then the only thing left to do is to recognize that x minus 1 is a common factor in the top and bottom, and we can cancel it. And that gives us our answer. 25. We have this awful looking expression, 9 over u plus 1 plus 9 over u squared plus u, and then u squared over u plus 1 minus 5u plus 6 over u plus 1. So once again, I'm going to combine both the fractions up top and both the fractions down below. But in order to do that, I need common denominators. So one thing that I'll do is I'm going to factor that denominator here in the second fraction. There's a common factor of u, which can be pulled out. And that's useful because now comparing the two denominators, I can see that both denominators already have a factor of of u plus 1. And in order to obtain common denominators, I just need to multiply top and bottom of this fraction by u. So I'll do that right here. Okay. The two denominators here are already common. Like I already have a common denominator of u plus 1, so I'm ready to... I'll just combine those right now. But once again, you've got to be careful. I mentioned this in the previous problem. Whenever you're subtracting a fraction with multiple terms, like you're subtracting this fraction and this fraction has multiple terms in the numerator, the minus sign needs to apply to all the terms in the numerator. So minus 5u minus 6. Okay, watch out for that mistake. Then, let's see. In the numerator, I have that common denominator of u times u plus 1. Combining the two numerators, I have 9u plus 9. In the bottom, I have u plus 1 over, or under, u squared minus 5u minus 6. Okay, I can tell that, like, so I could keep it, change it, flip it right now, because I have one fraction divided by another, but, like, I'm pretty sure that I can cancel some stuff before I even, like, do that. Because 9u plus 9 has a common factor of 9. If I pull out the 9, I get a u plus 1, and then I have u times u plus 1. And so in this numerator fraction, the u plus 1s are going to cancel, and I feel like it kind of makes sense to do that cancellation before I keep it, change it, flip it on the larger fraction. This numerator here, I don't know, like maybe that also factors nicely. I need a pair of numbers that multiply to -6 and add up to -5. I think that's u minus 6 times u plus 1, right? And yeah, sure enough, like the u plus 1s also cancel down there. So after canceling, in the numerator fraction, canceling these two u plus 1s, I have just 9 over u. And in the denominator, after canceling those two u plus 1s, you do just have a u minus 6, but the thing is I really want to write this expression as one fraction divided by another fraction. So like, I'm actually going to keep the denominator of 1 there because I just really want to have one fraction over another fraction. I feel like that makes it easier. So, okay, so now I'm ready to keep it, change it, flip it. So it's 9 over u times the reciprocal of the bottom guy. So that's this. And then, so I'm multiplying across the top and the bottom. That's 9 over u times u minus 6. And that's our answer. 26. We have another complex fraction monstrosity, another abomination, offensive to God. Okay, so I want common denominators because I once again, like I want to combine all three of these terms into a single fraction, and I want to combine all of those terms into a single fraction and then keep it, change it, flip it. So I need common denominators between all these guys and between all these guys. I think I can make all the denominators m squared. So in the numerator, I can multiply the 5 top and bottom by m squared. So I get 5m squared over m squared. I can get an m squared here by multiplying top and bottom by m. So I get m over m squared, and then I don't have to do anything to the last term. And then in the bottom here, I can also get a common denominator of m squared. I just need to multiply top and bottom of this guy by m. So 2m over m minus 2 over m squared. Oops, wait, hold on. 2m over m squared, my bad. Right? Okay, cool. So everybody has a common denominator. I'm ready to combine the fractions. So in the numerator, I've got that common denominator of m squared, and then these three terms add up together. So that's 5m squared plus m plus 6. And then in the denominator, I have that common denominator of m squared, and in the numerator, I have 2m minus 2. 1 second. Hi, I'm recording a video.
What?
I'm recording a video. I'll be done in a sec.
Okay, sorry.
No worries. Sorry about that. Okay, so yeah, I mean, I'm kind of ready to like keep it, change it, flip it, but I think that there's stuff that can be factored, and I feel like I kind of want to just do that right now. I mean, you could do it later, like it doesn't matter, but I wanna factor stuff now. So this guy here, 5m squared plus m plus 6, how does that factor? Let me think. I want a pair of numbers that multiply. Let me just do this on the side. I just want to factor 5m squared plus m plus 6. You can factor this however you want. Like you can draw a box. I don't like guessing and checking. So what I want is a pair of numbers that multiply to 30 and add up to 1. I don't think there is any such number. Oh, you know what? I made a mistake here. There should be a minus sign here. Yeah, there we go. Okay, so I want a pair of numbers that multiply to negative 30 and add up to 1. Yeah, so like 6 and negative 5 would do the job. So I can rewrite that middle term. I can split the middle as 6m minus 5m minus 6. And then I can pull out an m from the first two terms and pull out a minus 1 from the second two terms. And then there's a common factor of 5m plus 6 in the two terms. So I get m minus 1 times 5m plus 6. You may or may not be familiar with that method of factoring quadratics like this. It's called splitting the middle. I love that method, but if you don't know what it is and you just like draw a box, like that's totally fine. Anyway, so back to this problem. The numerator factors as m minus 1 times 5m plus 6. I don't know if there's much reason to do that. Oh yeah, there was. I see why. And then here, 2m minus 2, you can pull out a 2 and get an m minus 1 there. I have a feeling like those two factors of m minus 1 are going to cancel. So I'm going to keep it, change it, flip it now. So keep the numerator, m minus 1 times 5m plus 6 over m squared. And then times the flip, the reciprocal of the bottom, so m squared over 2 times m minus 1. So you multiply across the top, you've just got all these factors, m minus 1 times 5m plus 6 times m squared. And then in the bottom, I've got 2m squared times m minus 1. There's a lot of cancellation. The m squareds cancel and the m minus 1s cancel. So I think you're just left with 5m plus 6 over 2 quantity m minus 1, and that's our answer.